Good morning all. Today I am going to give a lecture on moment of inertia. Actually, I'll take a previous lecture also on moment of inertia, that is mass moment of inertia. Today I will discuss about area moment of inertia. Actually, moment of inertia we can find out in terms of mass also and in terms of area also. Now the question is, what the use of area moment of inertia? Actually, sometime we need to design if we need to design a beam or we need to design a column, and I want to give a rectangular size. Okay, if that was in rectangular size, I have to design that particular column or beam. Okay, and we need to find out the bending resistance, the capacity and all. The bending resistance we can find out with the help of moment of inertia. How can? A term is section modulus that is used to find the resistance against bending. The section modulus is nothing, section modulus is a geometrical property for a given cross section used in the design of beam or flexural members. Section modulus can also be defined as the ratio of moment resisted by the section to the stress in the extreme fiber, which is equal to yield stress. Section modulus is the direct measure of strength of the beam. Okay, remember this line. Section modulus is the direct measure of strength of beam. Higher the section modulus, higher will be the resistance against bending. Okay, like if we find out the value of IXX, okay, and the IXX value is higher than IYY, I can easily say that this section have high resistance against XX. Okay, in which side moment of inertia is higher, that side resistance is higher. So the use of moment of inertia you can understand with this. Now the section modulus, how related with moment of inertia? Section modulus is nothing, it is moment of inertia, the ratio of moment of inertia with the neutral axis of extreme fiber. Okay, so it is directly proportional to the moment of inertia. If moment of inertia is higher, then section modulus is higher. Come to the next slide. Two theorems that is important to find in moment of inertia to improve the use of that moment of inertia. We can find out the values about x6 and yy, that is CG, centroid, about the centroid. If we want to find out the moment of inertia in any other axis, okay, then at that time what we can do, we can use the parallel axis theorem. In our previous lecture we discussed about it a lot of. Okay, so in this lecture very thoroughly we can easily in some terms I can define the parallel axis theorem and perpendicular axis theorem. The parallel axis theorem is easily we can find out moment of inertia about any axis with respect to the our centroidal axis. Okay, like Ig is the value of moment of inertia in the neutral axis, and AB is the reference axis, any which we can take. Okay, we can easily understand it like this is our any body. Okay, we need to find out the moment of inertia of that body. We already know the moment of inertia of that body in the IXX and IYY. Okay, in the axis of y and x. But we need to find out the moment of inertia about AB. Okay, if we need to find out the value about AB, we can use the parallel axis theorem. That is nothing, it is IAB is equal to IG plus AH bar square. The IG is the moment of inertia about neutral axis, A is the area of that particular section, and H bar is the distance of that centroid, this centroid to the reference axis. Okay, understand it. The H is nothing, it is the distance between CG to the reference axis that is given to you to find out the moment of inertia. Okay, now the perpendicular axis is nothing, it is used to find the value of moment of inertia. To find the polar moment of inertia, that is simply the addition of moment of inertia in xx direction and yy direction. I can easily say that the perpendicular axis theorem says that the polar moment of inertia is nothing, it is the addition of ixx and iyy. Okay, now some few values that is the moment of inertia, few values are given here. If I can if I need to find out the moment of inertia of this rectangular channel. Okay, the moment of inertia of this rectangular channel in Ix is simply BD cube by 12 and Iyy in DB cube by 12. The value come from the moment, we find out the moment of inertia of this standard section. These are the standard section, rectangular section, triangular section, circular section. Our question that is come in AKTU, the question are like the I section. We need to find out the moment of inertia of I section. We can say that the 3 rectangles are there. Okay, we need to find out the moment of inertia of 3 rectangles. Okay, so we can easily find out the question in AKTU like this. Okay, like T section, we need to find out the moment of inertia of T section. We need to find out the moment of inertia of L section. Okay, these are the question that is come in AKTU. So we can easily understand that this section can be made with the help of this standard section. Like these 3 section can be made by rectangular standard section. Now the question is like this one in AKTU. 2 section are there. One is triangular, another is semicircle, another is semicircle. Okay, so by this you can understand that if we need to find out the moment of inertia of AKTU question at that time, this is simply based on the standard section. Okay, that is rectangle section, triangular section and the circular section. The value, the Ixx value and Iyy value we can easily find out by the method like wait a second, we can easily find out it. Okay, take a strip like if we know that these are the axes, like this is x-axis, this is our y-axis. We need to find out the value of Ixx. Okay, if we need to find out the value of Ixx, I can simply say that this is the formula of that moment of inertia, that is second moment of inertia. That's why it is called y square dA. Okay, now we need to find out the value of this. How can we find out the value of this? We just need to know dA. Okay, dA, that means I'll take a section in the reference of x-axis. Okay, this is a section. The depth of this section is dy and the width of this section is simply b. So I can say that the dA is nothing, it is b dy. Okay, it is b dy. I can put this value y square b dy. Okay, we know that b is constant, come it outside. Now the value is y square dy. Okay, we need to give an integration of that equation. Okay, take integration in some limits. The limit of this we can understand. See, this is the value y. Okay, this is y distance from the neutral axis. So I'll take the value from neutral axis. The neutral axis value is 0 and this is our, the total value is d b. Okay, so if I take it from 0 to, that means it is d by 2 and this is minus d by 2. Okay, so the limit of this is simply minus d by 2 to d by 2. Okay, integrate it and we can easily find out the y cube by 3, the limit d by 2, put it and the value is bd cube by 12. Okay, every section moment of inertia you can find out easily with this approach. Okay, see, the Ixx is bh cube by 12. Okay, similar in triangular section we can, okay, like in our next, if I want to find out the triangular section moment of inertia, I'll take a strip. Okay, first of all show the axis. The axis is x, y. Okay, now we need to find out the moment of inertia Ixx, simply y square dA. Okay, find the value of dA. dA value in this b1 dy, because the width is different. Okay, how can I find out the b1? Easily we can find out the b1 by similar triangle theorem. b1 by b is equal to h1. Okay, this is our, this distance is y, so I can easily find out the B1 value. The B1 value is y square B1 dy. Put the value of B1, that is y square B by h minus y dy. Okay, integrate it. The equation limit is simply, you can understand, I'll take the y value from this is 0 to h. I can give the limit 0 to h, put it, solve it, and the value is bh cube by, solve it, the value is bh cube by 36. Okay, so we can find out the values by this approach easily. Okay, the value is ixx bh cube by 36. Okay, in every section I can find out the moment of inertia with this approach. Okay, it is very easy approach to find out the moment of inertia of standard section. Okay, first of all, we need to understand how can we find out the moment of inertia of standard section, that is rectangle, triangle, circular. Okay, if we need to find out the circular section, how can we find out? See, I need to find out the circular section moment of inertia. Wait a second. Again, make a circle. Okay, fine. Make a circle. Define the axis. Same stepwise we can find out, define the axis. Okay, now take a strip. In this, the strip is like this. Okay, this strip make an angle theta. Again, the formula is ixx is equal to integral y square dA. Put the value of dA. How can you find out the value of dA? First of all, we need to put the value of y also. See, the y is the distance from reference axis to the strip. Okay, this is y and this is our x. So easily by triangular theorem, I can say that x is nothing, it is r cos theta, and y is r sin theta. Okay, put the value. Put the value of y, r sin theta. ठीक है, r square sin square theta. Put the value of dA. How can find out the dA value? See, this is the strip. We know that this value is r d theta, arc approach r d theta, and this value is dy. So I can say that this is r d theta d. Okay, sorry, this is radius, so dr. We can see that d theta, dr, two values are there. So there is two integration. One is for 0 to r, another is for 0 to 2 pi because it is circle. Okay, if it is a semicircle, then 0 to pi. If it is a quadrant circle, it is 0 to pi by 2. Okay, now solve it and find the value of, that is pi by 64 d the power 4. We can easily find out by this approach. Okay, so all these values, all the moment of inertia of a standard section, we can easily find out with the approach of make axis, find the dA, put it, and find the ixx and iyy of standard section. Okay, all the formula that is written here are find out easily with this approach. Okay, first is rectangle. Now I suggest that remember these values. I know it is easy to find out the values, but you don't have enough time in AKTU questions. So first of all, you find the standard value, then you put it. It is a lot of time taking process. So I suggest that remember these values, like the moment of inertia for rectangular section for x-axis is bd cube by 12. Okay, in y just change the cross section dimension, like b converted into d and d converted into b. When see, if this is the reference axis, at that time this is b and this is d. So just convert b into d, d into b in formulas, and you can find out the values of iyy. If I want to find out the value of iyy, I simply say that similarly db cube by 12 is the formula for iyy. Okay, so all these formulas, ixx, bh cube by 12, iyy, hb cube by 12. Okay, remember it. The jc is defined polar inertia, polar moment of inertia, that is nothing, it is ixx plus iyy. Add both the values and you can find out the polar moment of inertia. Okay, the ix and iy, these two values are given with the base. Okay, upper two values of moment of inertia are about neutral axis. Okay, other two, that is given about the base, the extreme neutral axis, that is extreme axis, you can say that is y, the extreme left, and this is extreme bottom, that is x. Okay, we can find out the value from the base and the left. Okay, you need to remember just these two values. Okay, other values you can find out easily with the parallel axis theorem. So I'm not suggesting that remember all these values, you just remember ixx iyy. If you need to find out the value of moment of inertia in any other section, at that time what we need to do, we just use parallel axis theorem and put all these ig, a, h bar value and find the value about any reference axis. Okay, fine. So the value for rectangle, simply remember bh cube by 12 and hb cube by 12. For triangle, remember it, bh cube by 36 and hb cube by 36. For circle, remember pi d the power 4 by 64 in terms of dia terms. If we need to remember it in r terms, you can remember it in r or dia. You know that d is nothing, it is 2r. Okay, if we need to remember in dia form, it's okay. If you want to remember it in radius form, it is also okay. Okay, whatever you want. In radius term, it is 1 by 4th of r the power 4. You can change. Okay, you can change and check it. Other, for semicircle, remember it. If for circle it is pi by 64 d the power 4, for semicircle it is simply half of that value, that is pi by 128 d the power 4. Okay, and in terms of r, it is 1 by 8th. In quadrant, it is 1/4 of circle. Okay, so just divide it by 1/4. Ellipse, you don't need to remember for AKTU. Okay, it is just for knowledge. Okay, now this is the basic of moment of inertia. Now the problems that come in AKTU, what type of problem provided us to solve, that is like L section, T section, any other different section, that is the composite section made by different shapes. Okay, so the first question, very simple, that is L section. We know that the neutral axis lies in some like here. Okay, this is our x, or this is over, it is near about. Okay, this is y. The value of that x bar, okay, value of that x bar, if I find it with the extreme bottom, if I find it by extreme left, this is something y bar. Okay, I assume it. You can easily find out the centroid of question. In our previous lecture, we defined it properly. So I think you are able to find the centroid of any section. Okay, how can we find out the centroid of any section? If it is a composite section, like there is some rectangle or a triangle or circle, we just cut it in some particular shapes. Like if this is our composite section L, okay, I break it in two shapes. One is this is our first section, another is, I break it in two section, another is this rectangle is our second section. Okay, I break it in two sections. If this is something U shape, I break it in three sections. Whatever is easy to me, I break it. Okay, the reference values I know about rectangle, triangle, circle, semicircle, quadrant. All the questions are related to this particular reference type of shapes. So we just need to break it, our question, to these known values. Okay, the known values for rectangle, so I can break it in rectangle. Two rectangles are there, 1, 2, and I can easily find out the centroid and moment of inertia. First centroid, I can find out the centroid by the formula, that is A1x1 plus A2x2 divided by total area. Okay, in our previous lecture we discussed about it, how can it come. Put all these values. A1 is what? Area of that particular section, that is 5 into 20. Okay, that is 20 is base, 5 is width. Okay, so 5 into 20 is the area. Another, the area of this A2 is what? A2 is A1 simply 5 into 20, A2 क्या आ गया? A2 is 5 into 16. Okay, sorry, it is not 16, actually 5 is minus by 16, 16 minus 5, it is 11. Okay, it is 11. Okay, A2 and A1. Now we need to find out the x1 and x2 and y1 and y2. How can I find out the x1? X1, see, that means this value from this CG, the CG of this section is lies in here. Okay, if this is our CG, the distance of this 2.5. Okay, we need to 2.5. So I can, x1 is simply, I don't know this value, so I can say that our centroidal axis is this. Okay, this time I assume that my centroidal axis is this. All the values I can find out in this reference. If this is not our reference axis, there is some value, it is shifted by some value, that value is given by x bar. Okay, so the value of this from here, it is 2.5. Okay, and for this it is, this is our CG for this section. I can say that it is simply, this value is 5. Okay, and then 11 by 2, 11 by 2, this section is 11, right? This dimension is 11, 11 by 2, I can, it is 5.5, add 5.5 plus 5, this is 10.5. So I can say that the value of x2 is 10.5 and x1 is 2.5, right? I think it is very easy. This is our reference axis. I need to find out the centroid for this. So x1 is simply, the centroid of this is simply in lie in between. So 5 by 2 is 2.5. For this it is lie in between. So 11 by 2 is this value, and I need to find the value from this axis. So I have to add this 5. Okay, so the value is 10.5. Put all these values and find the x bar, and for y bar. Okay, the value of x bar is 5.34. So I can say that this is lie 5.34. This y axis is lie in 5.34 centimeter from left. So this is 5.34. Okay, so our axis is, our actual axis is lie here. Okay, so this is our neutral axis. Okay, I find out the y axis. Now I need to find out the x axis. Okay, where it lie? Simply for this, see, the CG of this section, the CG of this section. Okay, a1 y1, for this total 10, this value is total 10. I need to find out the value of CG. So I can easily say that the CG of this diagram, okay, it is 2.5, and for x-axis it is 2.5, and for y-axis it is 10. So I can see that y1 is nothing, it is simply 10 centimeter. Okay, for y2, check y2. This is our reference axis. Okay, this is our reference axis. For this CG, distance between CG and reference axis is the y1. Okay, and distance between CG and reference axis is y2. Okay, so y2 is what? It is simply 2.5. Okay, put all the value and find the value of y bar. Okay, so easily you can find out the centroidal values by these formulas. Finding a1, a2, x1, x2, y1, y2. x1 is nothing, it is the distance between CG and whatever reference line you take, like extreme bottom or extreme left. Okay, so at that time the distance from extreme left to the CG of that particular cross section. Come to next. What is the need of that CG? If we need to find out the moment of inertia, what is the need of centroid? Okay, I can say that sometime we don't need this. Okay, but if I need to find out the moment of inertia about some reference axis, at that time we use parallel axis theorem. For parallel axis theorem, we use this CG, the CG of that particular diagram, diagram to the distance from reference axis. So at that time we use these values. Okay, if the question is simple direct direct neutral axis, you can easily find out Ix, Xi, Yy. If you need to find out the parallel, if you need to use parallel axis theorem, at that time you use this centroidal value. Okay, how can we use this? See, for this section, okay, this rectangle section, the Ixx is what? BD cube by 12. Okay, I easily provide BD cube by 12. B is 5 centimeter, D is 20. 5 into 20 cube by 12 is the value about neutral axis of this particular diagram. Okay, about neutral axis of this particular diagram, but we need to find out the value about the neutral axis of this whole diagram. Okay, the whole diagram value is here, something bottom from here. Okay, so I can say that we need to put the value like if this is our reference axis. Okay, the value is 7.33 centimeter. Okay, 7.33, that means it is 2.33. Okay, the value is 2.33. This value is 2. Just a minute. Yeah, this value is 2.33. The total value is 7.33. This, so 5, this 5 plus 2.3, it is 7.33. So our reference axis is lie here. Okay, the composite section neutral axis is lie here and here. We need to find the moment of inertia about these reference axis. Okay, but the BD cube by 12 that I used for this section, this will give the value about this section. Okay, this section value. So what we need to do now? We need to use parallel axis theorem to take the value here, right? So B1 D1 cube by 12 for this section plus area of B1 D1, this particular section, plus H bar. H bar is what? This value. How can we find out this value? Okay, we know the total value of this, like 10 half is 20 half is 10. Okay, the value, this is 10. Okay, we need to find out this value. We know that this is 7.33. The rest value we can easily know that. So I can say that I just take 10 minus 7.33 and it will give the value of this. See, this is total 10, this is 7.33. Okay, if I subtract 10 minus 7.33, I can easily find out these values, and we need to find this is our H for this question. Okay, so it is simply our parallel axis theorem IG1, our first section, A1, that is our first area, H1 square. Okay, for another section, we know that it is a composite section. We have another section added in this. So we need to find out the value of this section also. So apply the formula B1 D1 cube by 12 B2. Use B2 because this is our 2 section. So B2 D2. Okay. Okay. This is our B2. For D, it is use H. So B2 H2 cube by 12 plus area of second section A2 plus the distance of second section. See, second section distance, it is 7.33, this value. Okay, we need to find out now the reference, first of all, the centroid of this section. Okay, because the value of Ig, that is B2 H2 cube by 12, is nothing. It is about this section. Okay, it is about this section. If the value is about this section, but we need to find out the value about this section, this is our H bar 2. Okay, this is our H bar 2. How can we find out it? The total value is 7.33. Okay, and this value is 2.5. Okay, so if I subtract 7.33 2.5 from 7.33, I can easily find this H2 value. Okay, see, 7.33 minus 2.5, find the value. It is the square, so minus don't affect, but when you use this, it is never in minus value, so always subtract the higher value to lower value. Okay, so 7.33 minus 2.5 you use in this. Okay, I hope you understand this. Now simply solve it and find the value 5443.90 centimeter. Okay, the unit of moment of inertia is meter the power 4, or you can easily understand that B is meter, D is meter cube, because BD cube by 12. Okay, so I can say that it is meter the power 4, or centimeter the power 4, or inches the power 4, whatever distance, in what terms the question is given, it is the power 4. Okay, same as for circle, you understand that pi by 4, d the power 4, dia, meter the power 4. In all questions, the unit, in all terms, the unit is meter the power 4. Okay, so in there the question is in centimeter, so the value unit is centimeter the power 4. Now IYY. In previous, now we find out the moment of inertia about this axis. Okay, now I need to find out the moment of inertia about this axis. So what we need to do? We just need to see this section from here. Okay, if I see this section from here, I can simply understand that this is our B, this is our B, and this is our D now. Okay, this is our D now. If I see it from here, I can say that this is our B and this is our D. So B converted into D and D converted into B. Okay, so I easily use the B1 in place of H1, H1 in place of B1. Okay, so H1 B1 cube by 12 is moment of inertia about the centroidal axis of that particular section. That means if first section is first rectangle, so it will give the value about first section only. Now see, same, I need to I'll take the value from here. Okay, the reference axis is this. Okay, this is our neutral axis of this particular diagram. I need to find a value about this axis. So what we need to do, our H bar, I can say that again, our H bar in this question is this horizontal value, it is this. Okay, so this is what it is, 2.5. If total value is our 5.34, the total value is 5.34. Okay, I'll just minus 2.5 and I can easily find out the value. Okay, so our first value simply 5.34 minus 2.5. Understand? Put all these value and find the value of IYY1. Okay, I need to find out IYY2. So what we need to do, first of all, this is simple again. Okay, we need to find out this value again. See, this is our I can just wait, I'll make a new diagram. It's like this is our make a new diagram. This L section. Okay, our reference axis is here. Okay, just one axis I'll make here to make it clear. Our neutral axis of this section, first section is this. Okay, the distance of reference axis. Okay, I'll continue it in our second lecture. Okay, thank you so much to listen.